Welcome to HP Tuner's Ford Gen 2 Coyote Training Part 14. In this training tutorial, we're going to be taking a look at working with our closed loop fuel correction, understanding our short and long-term corrections, and how the front oxygen sensor is going to play a role in the closed loop feedback, determining how much fuel we need to inject into our engine. We have a lot to cover and to talk about. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our closed loop fuel correction in our Gen 2 Ford Coyote applications. Our closed loop fuel correction makes sure that we're always delivering the proper target EQ ratio or target air fuel at any given operation point as our engine is running. The Ford Gen 2 Coyotes are going to be unique in where they have full-time closed loop. So at idle, part throttle, even at full throttle, the engine control module is constantly monitoring what our measured amount of lambda is going to be from our oxygen sensors. That's going to be essentially giving us the oxygen content in our exhaust stream. And it's going to compare it to what we have for a desired target lambda or target air fuel. And then it's going to be making adjustments so that we are always reaching that desired target. Now there's going to be limitations to the system, but it works extremely well and it is extremely quick. This is going to make sure that we always have consistent fuel delivery with our Gen 2 Coyotes. We're going to break down how the closed loop works, the tables associated with the closed loop. We're going to go through explaining some of what the tables mean, and then we'll take a look at a data log to review some bits of data that we need to know and be familiar with so we can evaluate how our vehicle is performing and looking at our closed loop behavior. Let's jump in here. Let's open up a calibration file to get this tutorial started with. I'm going to go in here to the File Open section and then move into my desktop here. I'm going to go to our HP Tuner's Gen 2 Coyote folder, and then we're going to move in here into our Mustang example files subfolder, and then finally in here to choose any of our calibration files from any of the folders here. I'm going to grab a 2017 Mustang GT, grab this file. You can open up your file if you've read that from your engine control module or any of the files that I'm looking at here to follow along with the tutorial. Everything that I'm going to outline in this tutorial should be found in your calibration file. So all the tables and all the information is going to be the same across all the Gen 2 Coyotes. Let's click open here and let's open up that calibration file. Okay, so what we're going to do now is locate where we have the tables associated for closed loop behavior. And we'll break down closed loop just in general terms, and then we'll talk about the specific tables and how they all fit together. Let's go up here into our engine tab, and then we're going to move from our engine tab here. You see there's general. We're going to move over here into fuel, and then under fuel, we have these two tabs here, oxygen sensors, and then open loop base. These are all going to go play a role hand in hand with each other in making our engine run in this closed loop type of behavior. Now, the open loop base is going to be when we're in open loop. That's when we fire off the engine and it's running in a cold condition, or if the oxygen sensors fault for whatever reason, the primary oxygen sensors fault out and it can't trim off a bad signal, then it could go into open loop. Primarily what we're going to be looking at here is the oxygen sensor tab. This houses everything for the closed loop behavior and also how the oxygen sensors function. We'll find we have a ton of different parameters or tables that we can start to work with here and program. Let's now just talk about closed loop behavior in general. What is actually going on and how the system works. When we're talking about closed loop fuel correction, we're going to be able to specify a desired target air fuel or target lambda EQ ratio when we're at idle and part throttle conditions, and that's known as stoichiometric. We'll find that we want to command 1.0 EQ ratio or 1.0 lambda, or the gasoline petrol equivalent of 14.7. So this is what we want to run at. This is the target air fuel we want to run at when we're in those conditions. This gives a balance of emissions and power output from the engine. So and also for fuel economy, it's also going to be another aspect to this, but that's what OEMs always shoot for at idle and part throttle conditions, stoichiometrics. That's 1.0 lambda, or again, 14.7. We're talking about the gasoline petrol air fuel scale. So in order to make sure that we're always running at that specific target that we'd like to be at, we have front oxygen sensors that are mounted in each of our exhaust manifolds. Those are measuring the oxygen content in the exhaust stream. They'll report back to the engine control module what that reading from the sensor is going to be. So that's the actual air fuel or actual lambda reading. Well, if we have a target lambda or target air fuel reading that we'd like to be at, and we have our actual, we can then measure the difference between the actual and the target or the desired amount that we want to run at. That's known as our lambda air or air-fuel error, depending on what unit scale you want to work in. That error is used to drive the closed loop behavior. So if we're finding that our oxygen sensors are reporting that we have a lot more oxygen in the exhaust stream, that means we're running at a leaner mixture. Well, if we're trying to run at, let's say, 1.0 lambda or 14.7, and we're measuring something like 16:1 air-fuel, or the equivalent of something like 1.1, 1.15 lambda, that means that we're leaner than the target. By knowing this, the engine control module is able to look at the error and then start to ramp up the injector pulse width so we richen up the fuel delivery to the engine, or we increase the fuel delivery to the engine so that we're going to be putting more fuel into the engine, and then we'll have less oxygen content in our exhaust stream, which will bring down the reading and get us closer to the desired target. Likewise, if we're going to be delivering too much... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.